Assalamualaikum warahmatullahi wabarakatuh. Today we continue our next topic of applying the evolutionary algorithms into solving the economic dispatch. So we will emphasize on genetic algorithm. Okay. So because of this is the well-known algorithms when we talk about the evolutionary algorithms optimization. Okay. So first we will look at the binary. So basically GA consists of several types. So one of the famous one is the binary algorithms. So binary genetic algorithm, normally when we say about the genetic algorithm, normally we refer to the binary genetic algorithm. Okay, basically it's a stochastic method that applied the model of biological processes to solve optimization problem. So GA allows a population composed of individuals to evolve under specified laws to state maximize the fitness or minimize the cost function. Normally when we say about minimize, we want to minimize the cost, the loss, and etc. When we want to say about maximize or fitness, normally is maximize the profit, okay, maximize and etc. So these two function basically interrelated. We can make inverse of the cost will become the maximize, or inverse of the profit become the minimize. Okay. So the technique is initially developed by Holland and Company. So GA can be applied using binary and continuous approach. So this is the example of the analogy between numerical GA and biological genetics. Basically, we have a representation of, let's say we have a dog here, a binary code of that represent the dog. Let's say 101101 is this type of dog, 010001 is this type of dog, and so on and so forth. Okay, and then the dogs bark and receive rating. So this is how the rating in terms of numbers. Okay, and then we select dog to be made. So let's say we select these two dogs to be mated, and then it will consist the offspring or child. Okay, let's say this one we call the this is the chromosome of the these dogs, and then each values of these binary numbers will be mated. So let's say this one is only 1, 2, 3 digits will be interchangeable between these two dogs. So we obtain the child. This one is parent number 1. This one is parent number 2. So consists of child 1 and child number 2. Okay, so and then some iterations in order, because when we use this concept, sometimes you stuck in a local optimum. So local optimum, because we want to find the global optimum. Okay, so that's why sometimes we will introduce the mutations in order to increase the probability of the solution to be find the global optimum. Or we can say that the crossover is the exploitation process, and mutation is the exploration process. Okay, when in optimization, these two mechanisms need to be balanced in order to obtain the good results. So this is the flowchart of binary. So we define the cost functions, the cost, the variable, and then select the GA parameters, and then we generate initial populations, So normally GA operated or works in the populations. Let's say we have 20 populations, and then we decode. So in GAs we have encode and decode process. Encode and decode. So because our uh, process in terms of the binary, or sometimes let's later we look at the continuous. So for we need to encode first, encode the variables to be optimized into some binary numbers, and then in order to find the to run the or to evaluate, we must decode first the chromosome. Okay, and that's why you said here we decode the chromosome, we find the cost functions, and then we select the mate. This one is called selection. And then mating we use crossover, and some by using probability maybe 0.95 or 95%, and then 5% is using the mutation. And then we check the convergence. If not converge, it will process, it will be uh, reiterate until maximum iteration. Okay, this is the flowchart of binary GA. So basically the GA begins by defining the chromosome or an array of variable values to be optimized. Let's say when we relate with the economic dispatch, let's say we have four generators. Okay, we have four generators, PG1, PG2, PG3, PG4. So this value need to be encoded into the variable number, into the binary numbers. Let's say we use four binary numbers, so in randomly. Okay, so this one have their minimum and maximum for each generator. So we need to do the encoding and decoding later. I will show you. Okay, so the GA begin by defining the chromosome. So in the chromosome have n variables. So let's say we have this one, like this one. So we have P1, P2, P3, and P4. So this is your chromosome for population number 1. Okay, so let's say we have 20 chromosome, so we have 20 populations. Okay, and for this one is the example to search the maximum elevation of a topological graph. Topological map requires cost function with input variables or longitude and latitude. Okay, and then from there we use the functions. So for this one we use the function, and then to find the cost is using the minus elevation, because we want to find the maximum, right? Maximum elevation. But normally when you do the algorithms, normally we use minimum. So when you do negative, we become the minimum, right? So that's why when the elevation is maximum, you just times the -1. Okay, and then this is the encoding. So basically for the variable encoding and decoding, since the variable values are represented in binary, there must be a way to converting continuous value into binary and vice versa. So that's why we call it encoding and decoding. That's why the quantization samples of continuous range of values and categories, the sample into the non-overlapping subranges is very important. And then the unique discrete value is assigned to each subrange. So the difference between the actual function value and the quantization level is known as quantization error. So this is the figure 3 shows the example of the quantization of Bessel function. So this one is the, suppose your result in terms of binary, but when you do the digitizations, so you quantize. This one for using the 6-bit quantized version for the same function. So we got error here. Okay. So let's say we have our representations. So for this one, for example, for this example is the longitude and latitude. So we have 2, 4, 6, 2, 4, 6, 7, 7 digits of binary number. So basically this binary is represent of this value. Okay. This one is terms of the value of decimal 1 to 128. This value is between these two. Okay, so the chromosome translate into matrix coordinate. Let's say we have 99 and 25, or longitude and latitude 105. So this one you need to representing these two values into the longitude and latitude. Okay, this is the example of decode the binary strings. So later we will look at in details how we want to decode and encode the power generation of to solve the economic dispatch. Okay, next is selection. Normally we will use we call it roulette wheels. So this is how we use. So the other things is you can use roulette wheel or tournament. So depend on the problem that you want to solve. So normally I will use roulette wheel. Okay, never mind. Next, we go for the crossover. So basically this is the crossover happening. Let's say we have 1, 2, 3, 4, 5 digits plus this one is your parents. So let's say we have 1, 2, 3, 4, 5, and then we have two. We want to make a crossover between these 2 points. So these 2 will go to this parent to get the new offspring, and these 2 will go to this to get the new offspring. So you have 2 parents to obtain 2 offsprings. Okay, this one we call it 1-point crossover. Okay, this one we have 2-point crossover. So you have 2-point crossover. Let's say for this example, 1 and 2. So meaning that these 2 we go to this parents to obtain the offspring. So similar to obtain this offspring. So you get 2 new offspring values. Okay, so this is a crossover. Okay, so this is in terms of binary number, how the crossover is happen. Okay, let's say this one is the periodic and matrix process of single point crossover. It's just this chromosome, meaning that this chromosome number 3. So because let's say we have 10 chromosomes, so between chromosome 3, we call it ma. This one ma number 1 or mother is one, so father. Chromosome number 2 obtain 5 and 6, so new offsprings. Okay, so this is an example of crossover. And what is a mutation? Mutation is when you do the some alteration. The probability mutation is basically very low. It's around to 1 to 5%, meaning that several alterations, when the mutation is happen, you need to mutate in order to enhance the exploration process in order to jump out from the local optimum problems. So this is the example of mutation. This one, the population after mating, after crossover, and then this one, population after mutation. So sometimes you can get very good results by applying the mutations. Okay, but the problem is when you do the mutation, it's too many mutations. Sometimes your results cannot converge because it's very diverge. Give you divergence in order to obtain results. So that's all for this session. Next we will look at the continuous genetic algorithm in the next class. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much.